I think we can get started, so please take your seats. And we have a lot of ground to cover today. So I'm going to talk about one of my favorite topics, which is testing, and one of my other favorite topics, which is Kotlin. So let's get started right away. Testing tricks with Kotlin. So we as developers in the beginning always get this Hello World program. And the nice thing about this Hello World program is that we can just run it immediately, and we can just run any logic that we want. But what's cool about tests is actually that they kind of work in a similar way. So they don't have any parameters, so we can just call them anytime. And for me, I actually like to use test functions as so-called main functions with a name, like main with a name. And what's also nice about it is that you can actually have lots of different test functions in your code base, and you can just run them like thousands, like hundreds and thousands of tests, even in like seconds. And that is really cool. And you can also just run a single test. You can give it, you can give logic a name. And I think that concept is really, really powerful. But back to the test function. If we look at the test function, we have this same syntax. So we have no arguments. Here we have a test annotation. But again, we can just run the test without giving it any further arguments. And there's another thing that we know now with Jetpack Compose, which is with compose previews, we also have previews that we have functions that have no arguments. We can just run them, and we can just also give them a different name. But with these previews, we need our own eyes in order to check them. And also with the main function, it's the same way. But with the test function, it's really cool because we can actually call thousands of test functions in a few seconds. We don't have to need our eyes for checking if the output is okay. We can just rely on the assertions. And I'm going to come back to the composables, why the composables actually matter here back at the end of my talk. So stick around. And I'm going to give some tips here in the talk for making making things faster, so some tips. And if you can just take one tip with you at the beginning, it's that I recommend you to enable the Gradle configuration cache if you haven't done yet. Like, has anyone not enabled Gradle configuration cache right now? Or does anyone not what it is? Oh, who's using the Gradle configuration cache? Let's put it this way. Few hands go up? Okay. So please enable this feature because it's going to enable you to run tests much more quicker. So if you have a test run, you run it again, it's going to run much quicker on the second and third run. So my talks are, again, like live coding talks. So I will just open the IDE now, pray that everything works. And if not, then you're going to have some fun in me failing and seeing the errors actually and debugging this live. So let's go to an IDE now, where I set up the project. I have the code on GitHub online, so you can also check that out later. So here we have an app module, which is kind of an easy Android module, and here we have a Kotlin module, nothing fancy here, so Kotlin on the JVM module, not even using multi-platform in this project. And we're going to start with this test here, which is the sample1 numbers test. And we're going to start with running a simple test. Easy, right? So we can just click on the test, we can just run that, and now we can see, whoops, the test was failing. What happened here? So this code is actually generating numbers, and we want to generate 1,000 numbers, but we actually get 999. So let's actually see, this is not as we expected, so we go to the implementation, we can actually see, whoa, okay, this test here was filtering out an element. So it was basically removing one of these elements, and imagine how long it would have taken you to actually find that, like going through the 1,000 elements. Of course, we don't do that. We just do a test assertion, and then we can just see that immediately. And so now it's fixed. Now I can press Control-R to run the last test that I ran again. And for sure, it's green. But there are actually some other really, really amazing tips what you can do. So I just found out when researching for this talk that you can put your cursor somewhere. So here I put it on the test class. You can type Control-Shift-R, and then it's going to run all the tests in this class. Or I'm going to select a different function, Control-Shift-R, and then it will just run that. So again, let's run all the tests. And this also works, for example, here. So here we have generate numbers, a slow test, some others. And let's say we want to select all, but not the slow test. So now I press Control-Shift on these, and now I can just run these. Isn't that nice? So, and also during my research, I found another really amazing IntelliJ feature, which I didn't know existed. So I knew about Gradle continuous mode, where you can just run some Gradle task continuously and will actually watch the files being edited, and then you can run them again. But IntelliJ has a similar feature, which is this icon right here. Who knows that this exists? Like, hands up. Maybe 2 or 3 people hands up. Like, this is an amazing feature. So we can just type run automatically, and now I'm gonna change this file here, and I'm just gonna save. I didn't run the test, and now it runs itself automatically. So I'm gonna change it back, wait a few seconds, and then it's gonna run the test again. And this also works if we go to the implementation. So let's go to the implementation here. I'm just gonna put this code back, then IntelliJ will run the Gradle build again, will run the test again, and sure enough, the same thing later on. So we run automatically. I think this is an amazing feature, and I'm gonna use it more in the future now that I know that it exists. What's also nice, so let's actually put back here the error. So here, if you have like a big module graph or something, then it would be really cool to scroll directly to the stack trace. And you can actually enable this in the test runner settings. You can go scroll to the stack trace, which I have enabled right here. So if I run the test again, you can actually see that it scrolls immediately to the exception, which is really helpful, especially if you have like a long log line here. And again, if I would not have that enabled, running the test again, now it starts at the beginning of the log file, and I have to scroll down all the way to get to my exception. And this is much more useful. So let's keep it on. Okay, another really nice feature about Kotlin is that we can actually use backticks, and we can have white space in test functions. And IntelliJ will automatically tell me here, if I tap Alt-Enter, it will actually suggest to me that I can rename this with backticks. So I just press Enter twice, and now the function is going to be with white space. I'm going to run that. And then you can see that the test function now has a nice and readable white space sentence. So this is great. And now we can actually really fix the test again, so we don't run in this again. We run the test. Nice. So one more thing that I want to show you, like many people don't use this feature so much, but I think it's really great to actually use this from the IDE and not have some CI server then compile and then get the code coverage and run the test and then show you somewhere in some online tool. I prefer to have it right in the IDE, so we can actually run the full test class, and we can actually run it again with coverage. And now we can actually see the coverage. So if we go to the production code, we can now see here that this line is covered, but this other function is not. So we can see here, if we hover over this, that it has 0 hits, and the other one I think has maybe 1 hit. So now you actually know how many times your lines get executed in the tests. And we can actually close the coverage, like hide coverage here. So hide the coverage, so we hide that again. Let me check if I wanted to show one more thing on this entry. So here we have the test function. Yeah, also generating a new test is quite easy. So you can type Command N, and then you can just add a new test function. So this is quite handy. So you type Command N somewhere, and then you can create a test function or a setup function or anything. So let's create a test function. And by the way, you can also have white spaces here, and it will just do the backticks for you. So again, quite the handy tool, Command N, to create a new test. Okay, with that, we're going to move to the next example. So I'm going to do lots of different examples across testing in general, like lots of different testing tricks, which I actually found in production. And I want to talk a little bit about mocking. So mocking has a really bad statement, and like there's this argument sometimes about mocking versus faking, and I don't really like to get in this argument so much, but what I really like is to actually show you the information. If you use mocking, what you're getting into. And one thing that I actually want to show is, here I have one function without a mock, which is just using a fake numbers generator. And here I have the same function, which is basically doing the same thing, where I just use mock hey, but you could use any other mocking tool. And of course, here I just use assert that on a mock, which you should never do, but it's a talk, right? So I'm allowed to do that. And now let's actually see the performance characteristics of these. So let's actually run first the full class. And let's actually only select without mock and with mock to actually run only these. And now you can see that the without mock function was 4 milliseconds, and in some cases I actually saw it like 1 millisecond. And the mocking overhead is like already on my machine, which is insanely fast, like over 600 milliseconds. And you pay that cost every time your test suite starts running. So the subsequent tests will get quicker. But again, like if you run the test a single time and you have a mock, then already you're paying a huge performance hit. And that's because the mocking libraries use some tool which is called ByteBuddy, and they attach like a Java agent and they generate bytecode on the fly. And that takes some time to actually set up. Many people don't know that. Like, who didn't know that mocking has this performance overhead at the beginning? Like, I didn't know that. Oh, lots of hands go up. So now you know, and now you can tell your colleagues, like, why would you take the performance hit if you can just fake an interface quite easily? So again, something that many people don't know. So let me actually run the full test class again. So here we have another mock, and here we can see that the first mock actually pays this performance hit, but then the subsequent methods that are called in the test, they are quite faster, right? Because the setup is there. But still you pay this performance hit, and I think that if you have lots of modules, I think that you actually pay this performance hit for every single module. So if you have a slower machine, the setup can easily take like 1 to 1.5 seconds for every module. And then if you have like 300 modules, then do the math. It's a lots of time wasted. So I think, like you should know what you're getting into if you use mocking. Yeah, one more thing that I wanted to show here was basically, so if we use mocks, then another downside of using mocks is that you're basically creating a new class every single time. So you could just write a fake, and in many tests you can actually reuse the fake in many different test methods. So maybe 10 methods and you're using the same fake. Maybe you set some other arguments on the fake. But with mocks, every time you get a new dynamic class, and that brings complexity. So imagine having like 10 test functions, and now you actually have 10 different dynamic classes. And what I'm going to do here is I'm actually going to enter an error. So here I fake the generate even number, and here I fake the generate numbers. But here I'm using generate numbers. So this will now produce an error because I faked the wrong method, and the other one does not have a mock. But again, it's showing to me this at runtime, and I prefer to have these errors at compile time because it's much quicker to actually see them and then fix them while you're typing. So with mocks, you then don't get that safety. Okay, I'm gonna fix it again, and let's see what else I wanted to show. Maybe one thing that for many characteristics, maybe you have a view model and the only output you have is like a flow, like one state flow somewhere, but maybe the view model has like 10 different inputs or 20 different inputs. But then in the test files, where you actually use the fake, you could just enter your own flow data, like have every single test function have a different input and then like output of that view model, and then you can use the same fake in all the different tests. So again, more flexibility without fakes, without mocks. So I'm going to close these files, go to the other example. I'm going to hop over to the Android repo now, Android module. And here we're going to dive into memory leaks. So memory leaks can be really tricky to find. Let's look at this simple leak, and we have a harmless looking method, and it's looking so harmless that I'm not even gonna open the implementation because again, it's harmless, right? So what can happen? So we just run this method and we get the test, and 4 milliseconds, not too bad, like nothing's happening. I don't get an assertion, But actually now let's repeat running this for 1 million times. Notice that I'm using the underscores here. So I'm going to run this, and now I will actually get an out-of-memory error because something happened. We don't know why. Do you know why? No? Let's actually use one of my favorite tools, which I have been using in the last months, actually, to debug these kind of issues. So I'm going to hop over to a test function which I prepared, and I prepared a print used memory, which will just output the currently used memory. And now we can run the same code under test, and we're just going to repeat that 10,000 times. And then every 1,000 times we're going to print the memory. So only 1,000 times, because then it's easier to see the memory growing. And let's actually see that. So I'm going to run that now. And now we can actually see here that the memory is growing indeed. So we can see it's growing from 27 megabytes up to 340. But maybe it's just growing and the garbage collector didn't run. So let's actually make sure that the garbage collector did run. So in Java unit test, you can just call the garbage collector yourself. And then we're going to run the same test again. And sure enough, the leak is still ongoing. It would be so cool if we would have a way to actually inspect the memory of this program. But we need some time to actually attach the tool to it. So I'm now going to use this test function, and at the end of the test function, I'm just going to add a thread.sleep. Let's add the 5 minutes here. And now if I run the test function, then it will run to completion, so all the 10,000 iterations. And now it will keep on running. And what that enables us is we can now open a tool which is called Visual VM. So this is the tool right here. This is from Oracle. You can just download it on your machine. And you can basically see all the different Java programs on your machine right now here. So we can see Android Studio. We can see Visual VM itself, because it's also written in Java. We can see the Gradle daemon. Actually, there's 2 daemons right now. And we can see the worker, which is currently open. And I just double-clicked on this worker, and now we can actually monitor this. So here we can see the memory, like the current size, which is like 740 megabytes. And we can see the meta space and all other tools. And we can do a heap dump now. So we're still running this worker, we're still running this test. And you cannot just, do this with any test, but if you have a test suite, then you can just find out what your last test is. Then you can do the thread.sleep on your last test. So if you suspect a memory leak in one of your modules, then you have 1,000 tests, then just find out which one is the last running, and then you just add the sleep there, and then you get the time to actually do the heap dump. So now we actually do the heap dump, and already we can see there's a user class here which is having over 10 million instances. But you can also step inside. So we can actually click here and click on objects. And then we can actually see, and we can filter. We can actually filter here for my own package name. And sure enough, like we have 0 instances here, 1 instance of this unit test class, and 10 million instances of this user class. And what's nice is we can actually inspect every single instance and where it's coming from. And what's really nice here is we can actually go here. And there's a small icon here, which is called garbage collector root. And I can click on that. And what it's going to do, it's going to find the path to the root where this instance is hanging. And here we can see that the field that we actually were looking for is the ever-growing list field in our code. So we can actually now go back to the IDE. We're going to find the ever-growing list. OK. And sure enough, so here we have the harmless-looking method, which is calling the method leak. And then this one is actually calling 1,000 times. It's just adding items user to this ever-growing list, and it's never going to return that. And now we found our leak. But we didn't have a look at the single line of code to find it. So this is really great. This tool is worth using a lot. So, and I'm going to show this also because, let me remove this thread.sleep again. So here, we can actually see that it's, I want to come back to the mocking topic again. because also with mocking, you can actually have a leak quite easily. So here we can run this, and here we have a static method, which is not doing anything strange. So this is just returning a user. But now if we actually run this test, so we mocked it static, and then we can actually call this function later, and we will get the test user and not the other one from the real implementation. And this is some advanced stuff. And what we can see here is that the memory is also growing. And I can assure you, I tried many different things, like even unmock static. So you would say, he forgot the unmock static, so it's still hanging around, or he forget the clear all mocks. But I'm actually going to import that now. I'm going to run the method again to prove to you that this is indeed still leaking. So again, with mocking, sometimes you get a lot of advanced behavior that you really don't need, or maybe you don't even want to get into. And these memory leaks can be really tricky to find. So sometimes it's better to just use fakes in the first place. Yeah. So I'm going to close this file again, and we're going to jump to the next example. Flaky tests. So sometimes we have a flaky test. So for example, this code right here is just generating a 0 every 100 times. And if we run it right now, then let's see. Then we're going to see it succeeds. I can run it again. And if we're really, really lucky, we're going to see it fail. But again, this is not really helpful. So what I could just do, I could just copy this line here, and then I could run this from the command line. Let me actually reduce this down to 10, so it's a little bit quicker. So I'm going to go to the terminal, and here we can actually call the test. So here we actually executed 20 times in a for loop. Then we can call the test. So here we have the test with 10 times. And we're going to use this Gradle option, which is called ---- rerun, that makes sure that the test will run, and it will not just say, oh, the test did run, so I don't have anything to do. And then if there's a failure, then we're going to end the loop. So if I run that now, we're going to see it pass, and then at some point it should actually fail. Let's give it a small few seconds. If we're, yeah, okay. So now we have the failure, and we can actually open the file and dig into it. But what I found is that you can even, do this much better. So for example, if it's 100 times, then it might be much quicker to just do a repeat here of like 1,000 times. And then you can just run this code, and it's going to run much quicker. And you're going to find the leak immediately, this was like 30 milliseconds. So like a small handy trick, which is really, really simple to do, and then you can just find your flaky test much, much quicker. Okay, that was everything I wanted to show here. So let's switch over to coroutines. So with coroutines, I ran into an issue once, and this was quite a big project, and I didn't know what happened, and I tried to debug this issue for a few weeks of time. And then it actually hit me what was the issue. And maybe this information can be useful to you. I hope so. So debugging coroutines or flows in Kotlin can be a little bit tricky, especially if you accidentally create a new test scope, like a second one. And then you have 2 test scopes at the same time. Let me show you what I mean. So here we have a class which is basically just having a compute function, and it has a state flow which is number, so we can actually dig inside. So here we have a state flow, and we have a compute function, and this compute function will take the scope, it will delay for 1 second, and then it will set a value. And we can actually run this test, and now we can see that it completes, it's fine. But now if I actually, so this right here is a test scope. So we're passing the test scope from the one test function. So this is automatically creating a test scope for you. And it will also do that if you created your own test scope. So if you created your own test scope here, let's put it this way, I'm going to run the test again, then it's going to fail, because now we're using 2 test scopes. And what I found really helpful is that to find out if you're using multiple test scopes, of course, if it's not that obvious like here, so here it's kind of obvious, but maybe not to everybody. Maybe not everybody knows that one test is actually generating a test scope for you. So we can just run the debugger, We can run this test. And now we can inspect the memory of the test in the debugger. And we can actually, so here, right here, we can inspect the memory. And I'm going to look for the test scope instance. And for Kotlin, it's called test scope impl. So here we actually have test scope impl, and we can see that we have 2 of them. And now if we double click, we get a really, really nice view, which is that one of the test scopes is the one from run test, and it's actually saying like test started. And the other one is the one that we created ourselves, and the test is not started. So if you run the debugger and you see multiple test scopes, then you know that you definitely have a problem, and you should only be using one of these test scopes. So let's close this again. And let's stop the function. And let's actually fix this test again so it doesn't hit us later on in time. And so here I have an example of why this might be not that obvious. So of course in our big projects, sometimes we have these big dependency injection frameworks. Sometimes it's Dagger, sometimes it's Cone, but you name it. And maybe we're running the test and this is creating a test scope, and maybe we're just using the dependency injection and we're using our own test scope here. So now we actually got a problem. What do we do? So if we go back and we're going to run this test, I'm going to remove the ignore, run the test right now here, and then it's actually going to fail. And what we can do here right now is then we can actually fix the test. So we can actually make run test, use the test scope instance out of the dependency graph, and then we don't get multiple test scopes. So here we actually want to start coin earlier. Then here we get the test scope. So here we go, test scope equals coin. Oh, thank you, AI. And now we can actually say test scope dot run test, and now the test should be fixed. So now we're basically getting the test scope out of the coin graph. Oh, it's not working. Why isn't it working? No definition found for test scope. Yeah, that's why. So I didn't run it before, but we can actually have multiple here, but I'm not going to fix it, but you can actually call the test scope here. Here we can get the test scope. Oh, I'm actually going to fix it because it's quite simple to do. So here we're going to get the test scope. Get test scope. Anyway, I'm not going to do that right now, but you can trust me on this. You can actually get the test scope, and then you can run the test, and it's working. And that way you can be sure that you don't run multiple test scope instances. So again, adding the ignore. And going to the next example. Let's see how much more time we have. A bit. OK. That was a little bit quicker than I expected. So let's actually check in coroutines like what other things I wanted to show. So we have the test scope run test. And yeah, so we have the non-obvious thing that if the dependency injection is involved, we actually might have multiple test scopes. And that might be not be the best idea. I think I showed everything. So let's go to the thing that I mentioned earlier in the slides, which is that we have these preview functions with composables, and they are like test functions or like main functions. They have no parameters. We can just run them, and that way, right now, we can actually use screenshot testing. So you should actually check out. You should actually travel back in time and watch the talk by Sergio, because he has given like a really great talk on screenshot testing, and or just watch the recording afterwards. That's easier than building a time machine in the first place. So check out this talk on all the different screenshot testing methods. But I really like using Roborazzi. So this is using Roboelectric under the hood. And it's using actually a native rendering engine shipped inside Roboelectric. So with Roboelectric, which is a testing framework, you can actually fake some Android APIs and actually different Android API versions. And with Roborazzi, you can actually do screenshot testing for your views, for your composables, you name it. And here we have a composable, which is greeting. And so this code will not do anything because these tools are set up in a way that you actually have to tell them, now I want to record a bitmap, or I want to verify my code against my existing golden images. So we can actually call this on the command line. So I'm going to call this one here. So we're going to record the screenshots. And now it will run all the tests. So here of my module. And again, like I use some tools like Mockito and Robolectric, and they have some overhead. So this is a little, why did I not fix this? So there's a problem here. So we'll actually go to sample for flake tests and see which function was. This test will fail. Oh yeah, it fails because we actually made the flaky test fail. Actually, let's ignore the test for now. So it will not scare us. Okay, now running the tests again. I'm recording the screenshot with Roborazzi. And with recording, it will generate an image. So here I just passed the name roborazzi.png. And sure enough, we can now see hello droidcon Berlin 2024. Hello to you. And I think this is really amazing because we can now just go through our code base and we can just make screenshots, and we have the same power with the composable preview. So we can now watch these images, and we can even, like maybe we can generate an HTML file and we can just watch all our design system widgets there, or just the screens and everything with different data. But what's really handy about this is that, let's say we want to verify that that everything is okay. So we check these in, ideally not into Git, but maybe Git large file system or something, so some different location. And now we will actually verify that the same image will still make the same, so the same composable will still have the same UI output. And now we're running it, and we didn't change anything, but imagine you're upgrading the compose version, and you have like hundreds of these of tests. And now you can be sure that not a single pixel changed because of your compose upgrade. That is a really cool feature if you have set it up. But now let's actually, for the demo purposes, let's actually jump 1 year into the future, and let's try verifying that the image has changed. And sure enough, the test is now failing, and we can see the HTML report. We can click on it, and then it's going to say, well, here's some output, and here is actually an image, which you can view. I'm going to open that in a new tab, and then you can see that it actually created a div in the middle between our old version and the new version. So it knows something has changed, error, and then if I'm fine with this change, I can now run record again, and then it will make the new image my new golden image. Because I say, well, it's now 2025, that's okay, that's an intended change. So this is great, I love this. And yeah, I think we're near to the end of our talk. We're actually gonna go a little bit more into Robolectric. Let's switch this back to 2024. And I have one more example to show to you, which I think is really, really handy sometimes. So with Robolectric, again, you can mock Android, and you can fake out Android APIs, or maybe it's actually mocking. So what we can do, we have some code here, which is the service using location, and we have some service here. This is our code, and we're using the location manager from Android. And here we have a method which is just called isLocationEnabled, and it will just ask the Android location manager service if the location is enabled. And with Robolectric, we can create these things called shadows. So here we have our location manager, and again, it's the same code as you would expect. So we can just grab the context, get the system service, and now if we have the location manager, we can get a shadow of that location manager, which is a Robolectric concept. So now we'll actually get access to many more methods. Like for example, here we can actually call setLocationEnabled, setLocationMode, which don't exist on the location manager. This is a new API from Robolectric, which will now enable you to mock these things. So in our case, we actually want to say, here we have the location enabled, and here we have a test where the location is disabled, and then we expect our code to reflect that. That behavior. So now I'm going to run the test again. And sure enough, it works. So we can check that the location is enabled, disabled, and we have some other tests which is just calling the service, and it's putting in the context, and that is still calling Robolectric, but it will actually just call a different function. So nothing to be seen here. I just want to give another tip for you. So this can be really handy if you have a class and you have some dedicated Android APIs, and your focus on this test is actually to test these Android changes. But maybe it's not a good idea to use this in all your project because, again, like the setup overhead on my very quick machine is maybe 1.3 seconds. So this is only paid like upfront at the very first test, and then the next test will reuse that. But maybe it's not good, not the best idea to use this in every single of your modules or in every single test. So it's very good to actually not use mocking and not use row electric, and then you get much quicker tests, which is a very nice thing. And with that, I think I had everything that I wanted to show. So we're going to go back to the keynote, back to the slides. And that was everything I wanted to show you. You can find me on social media on Marc Reichelt, and I also put up the code on Kotlin testing tricks, and enjoy the conference.